Good afternoon, everyone, and thank you for attending today's webcast. Today's session is about introducing you to a soon-to-be released command in civil site design named Threads. And I think this new functionality is going to be a real benefit to you. This session will be recorded and available on YouTube, and we'll make it available via the welcome screen as well. If you do have any questions throughout the session, then please add them to the chat or Q&A windows, and I'll do my best to answer your questions. So Threads is a new command, and we do appreciate your feedback and also suggestions. So even after this session, feel free to contact us if you so wish. I will be running the software today on Civil 3D. This is a beta version that I have. But as you know, Civil Site Design runs on a number of different platforms, AutoCAD and BricsCAD as well. And this new functionality I'm about to show you is available for all platforms. So what are threads and why have we added them to the software? Well, this new functionality allows users to build up a sequence of actions into a computational workflow and process those actions on a single click. In civil site design, we have a lot of commands that are update or refresh commands, and a big part of threads is allowing users to tie these into the one process which you control. So commands like updating vertical geometry via the compute VC command, updating draped strings, rebuilding models, and even plan production like cross-section output or CAD output can be added as actions to a thread and processed on a single click. Today I'll be demonstrating a couple of examples of where threads will benefit you, but there are many benefits, and even here in the office we're discovering. If you work on larger projects, then this will be great for you because you can turn off a lot of the auto rebuilds in the software and rely on threads to update your design when you want. I think one of the biggest benefits is going to be the updating of string data. This is data that might reference a surface or design constraint. Currently in the software, I would need to open up the vertical grading editor, open compute VC from existing and reprocess the string. But with threads, you don't need to do this. You might use threads to update drape strings in your model, and the order of operation might be really important. So you might only want to update the drape string once other actions are performed. So threads allow you to easily order how these actions happen. Other benefits, as I mentioned, the plan production. So rather than updating cross sections, CAD output, even set out individually, you can create a thread to output all on a single click. So here on screen is a list of the actions that we've currently included. So you can get an idea of the types of things that you can process in a thread. Down the bottom, you will see that you can even add threads to other threads. And I guess this is where things can get a little tricky, but you might create a thread called plan production that does a bunch of stuff, and you might want to later add that to another thread. We will be adding more actions to this list over time, so do expect this list to grow. If you've got any ideas of certain commands that could become an action for threads, then let us know and we can see about slotting it in. Okay, so let's get stuck into the live demonstration. I'll just open up my Civil 3D. So the first thing you'll notice when installing this new version is a new button in the middle of your ribbon named, well, should default to being on Run Threads. When you expand out the bottom of the button, you will see another command called Thread Editor. You use that to build your own threads. So if I go and click on Run threads, it opens up a modeless window listing all threads that are available to me. Some of these are local to the project and others can be stored globally. So some of these threads down the bottom, expect those to be stored with the software, but as I said, you can create your own that are local to the job or save them to the global or settings folder for use with future projects. Now, to run a thread is pretty straightforward. All you do is you pick the thread from the list and then you select on the Compute Thread button. If you right-click on a thread, you can see that a menu appears, and I can click Run Thread from here as well. If I right-click, I can also open up the thread editor, which I'll talk a little bit about as well. As I said, you could also open the thread editor from the ribbon. So if I expand out Run Threads and click on Thread Editor, this is what it looks like, but I'll get into a little bit more detail on that in a sec. So what I wanted to do is just talk a little bit about this job that I've got open. This is a typical council project. It's a job that basically involves the redesign of some curb and channel on the left and the right hand side. And the curb and channels is matched to strings. So I'm using strings on the left and the right to independently control offset and level. So I'm just going to open up a cross-section window so you can see the cross-section. And you can see I'm not getting exactly 3%. It's a little bit off. I'll explain why. And I'm just going to open up the vertical grading editor for the curb. So what I'm looking at here is the new left edge of bitumen string. And you'll see as I move the levels up and down, I have full control over the crossfall of that curb. Now, how I've set this up, this particular string, in the Compute VC from Existing Data button, I have two entries in here. And the first entry, I've told the software to do a design by matching to one of those constraints. And I do that by using this constraints option. The next item underneath that is a smoothing. So I've used fit parameters to smooth my design in between those two bands. So rather than getting an IP at every section here, I've got a nice smoothed out design. So if I was to make changes to the main road levels, this string won't update unless I go back into Compute VC and I reapply, reprocess this. And if you've got a whole bunch of these types of strings set up, well, it's a little bit annoying to have to go through and update them all the time. With strings, you don't have to do that. So let me just demonstrate. If I open up the vertical grading of the main road and make some changes to the road, you know, the crossfall's looking quite ordinary, and you know, my string obviously isn't updating. So let me I'll just rearrange this so it's a little bit easier to see what's going on. Okay, so in this particular project, I've already created some threads. I just want to demonstrate first how they work. So I've got one in here called Road Update, and I'm just going to double click on that to open up the thread editor. Let me just move that out of the way here. So all this thread has been told to do is reprocess the vertical geometry of the left string and the right string, and then reprocess the design data of the main road. So in other words, once we've recomputed the vertical geometry of the strings, update the design data form and the variations which have been told to set the code to match those strings. Okay, so if I right click on Road Update, and click on Run Thread, you can see now that my design here is updated of my curb, and I'm now getting suitable crossfall. So let me just do that again. This time I'll change the main road, and let's lift it up so you can see that I'm getting pretty ordinary crossfall there. Alright, then I right click and run the thread, and the vertical geometry is processed. Now not only has that happened on the left hand side string, but it's also updated on the right side string as well. Let's do something to make it look a little bit more obvious, and something that's quite cool. So what I'm going to do is just add an IP on the main road, and I'll set that with a VC length. So you can see here I've got a curve added, and I'll just let's just change the shape of this road a bit. Alright, so you can see I've got a VC here, it drops down, I've got another VC here as well. Now when I update the string, we should see something that resembles the road and the two VCs. So let's right click, run the thread, and you can see that that profile of the curve is updated. Okay, so it saves me having to go in and update them individually. Right, so once again, if I was to open up the other side of the road, you can see that it's updated as well. I didn't have to go in and compute it individually because the thread has done that. So as I said, I think one of the first benefits straight up of threads is just recomputing strings that might reference constraints, might reference a surface, reference line, basically all the controls in here. The thread has just been told to recompute the vertical geometry. The next example I wanted to do on this particular project is rebuilding this intersection here. So I'm just going to open up Model Viewer and show you how it looks in 3D. So what I've done is I've formed this intersection using the curb return tools in civil site design, and I've modeled the roundabout using the roundabout command. Then what I did at the end is use the drape string command. It's one of my favorite commands in the software, to create some islands that match down onto Total Model. Now the final model was built using Model Builder. Okay, so the islands are matched down to Total Model, but I've used Model Builder to combine everything together. So one issue I might have, and you guys might have experienced, is if I change the levels through the road, then there's a few things that might need to update. And so I guess what I might do is open up the main road, and I'll just delete. Okay. Now I'm just going to raise the road up a little bit higher through that intersection. Okay, now it might be a little bit hard to see on your screen, but my triangulation through the intersection doesn't look too good. Those islands are no longer draping onto Total Model. My roundabout is lifted up. So we need to update some things and rebuild this this roundabout. So I've created a thread which is set up to rebuild this particular intersection, and I've just called it Model Update. So I'm just going to double click on that thread and show you how this one's been set up. So Model Update, I've added 4 different actions. The first one being compute all road objects, and you might be familiar with this command off the ribbon here, update all road objects. What it does is reconnect your curb return, or reconnect your curb returns, reconnect any cul-de-sacs, knuckles, etc. that you might have. So that's what that one does. Compute roundabout will remodel my roundabout, and then I've told the software to update the drape strings, so they'll match back down to Total Model, and then I've told the software to compute design models, and design models are anything that you might build in Model Builder, because remember, as I mentioned, everything is built or triangulated via my Model Builder model. So if I right click on the model update and run the thread, right, you can see it might be a little bit hard to see, but I've now updated that intersection. Everything is, I've got no triangles popping out. The intersection was reprocessed, the roundabout was reprocessed, and those islands were redraped onto total model. So this is another example of where you can use threads. Now, I've created 2 individual threads here, but you could just create the one thread that does every single update you ever wanted in the software. So then you only need to run the one thread. So now there's 2 examples. That's updating strings and updating an intersection with islands. I'm just going to jump across now to another drawing here and just show you a few other examples of using threads. And what I might do this time is create a thread from scratch and show you how the thread editor works. So the first thread I might create might be just to go and update the plan production for this particular road here, Marin Street. Now, for Marin Street, I've used multi-set-out, and I've actually done a set-out. I've turned the set-out points off for now, but I've outputted the set-out. So I want my thread to go and update the set-out. I might also add to the thread a cross-section update and a long-section update, and maybe we'll do some CAD outputting plan as well. So the line work I see here, just the auto design, auto line work, but I'll have the software output the contours as 2D polylines, and my other line work here is 2D polylines as well. Okay, so this time I'm going to open up the thread editor and I'm going to create one from scratch here. So to create a new thread from scratch, all you need to do is click on this button up the top right with the green plus, and then you give it a name. So I'll just call this one Plan Production. Now I can put a little description here about what this thread does. And so when you open up the run thread form, anyone who clicks on the thread will get a bit of a description on what they can expect it to do. If I want to use the thread for other projects, then I simply click on Add to Public Library, and then it'll be available all the time. So on the left-hand side here, we have the list of actions. So this thread, as I mentioned, will just be a plan production thread. The first thing I want to do is tell the software to update my multi-set-out command. So I go down to the list. Under plan production is update set-out. So to add the action to the list, 2 options. I can either select on this add action button, or I can double click on the action here. This form will appear. Now, multi-set-out is I guess a global command, so it'll update all set-outs that I have. So normally when you run these actions, you can pick strings or whatever that will be updated. In this case, all I need to do is pick the insertion in the list. So as I said, the order of operation is important. And when I add this action, I can add it directly to the top, to the bottom, or whatever. Doesn't matter in this case because it's the first one. So I've added updating of the set out. The next thing I'm going to do is output the contours as 2D polylines. So I'm going to double click on Output Model 2D Polylines. Now for this one, I have the option to pick either individual surfaces or models, or I can click on all. And the beauty of clicking on all is if I do add extra models to the surface, then when I run the thread, they will also be included. So in this case, I'm only going to output the contours for total model. Next, I'm going to output the line work, the design line work. Oh, sorry, that's what I did there. I picked the wrong one. Okay, so yeah, that was the line work. Now I'm going to pick on the contours. Sorry, so just above that is output contours, and I'm going to say output the contours for total model and add that to the list. And next I might choose to output the cross sections and the long sections for Marin Street. So I'm going to double click on plot cross section. For strings, you do have a few extra global selection tools here. So I could tell the software that I only want to plot out all curve returns, or I want to plot out all road objects. And then once again, if you use these global selection tools, and if I add other strings or roads or whatever, then they will be included next time you process. In this case, I'm just going to process the cross section for Marin Street and lower that to the bottom, and I'm going to update the long section as well for Marin Street and throw that down the bottom. So that's basically it. So I've told the software, when you run the thread, update my setout, output the 2D polylines for the design, output the contours, and update the cross sections and the long sections. Now, just another thing worth mentioning, you're probably aware of the drawing cleanup command. I can add this as well to the list. So sometimes you might want to do a drawing cleanup before outputting the line work, but I don't think it's going to be an issue in this case. Okay, so if I click on close and open up the run threads form, remember this is a modeless form that you could always have opened. In the list, you will see plan production. So I'm just going to right click and run that thread. All right. And then it's gone through and done everything that I said. So I've got the long section updated, I've got the cross sections updated for Marin Street, and my setout has updated as well. And all that CAD line work, so the contours are 2D polylines, and my road strings are also polylines. So whenever I update that string, run that thread, it's going to process all those outputs that I'd set up. It's really as simple as that. If I double click on my thread and open up the thread editor, if I wanted to, there is this checkbox here to turn certain actions on and off. So maybe I wanted to go, and next time I run it, I don't want to plot the cross sections and the long sections, so I tick that one off. And then if I rerun plan production, it does everything except plot the cross sections and long sections. The other thing worth noting is for my thread that I created, you can see that I reference Total Model and Marin Street. So I might want to run this particular thread, but rather than referencing Total Model and Marin Street, I might want to pick another road or surface. So when you run the thread, if I right click, there is this option to run thread with selected objects. And I'll just open up this form. I probably won't run it. But here, rather than processing Marin Street, I could process car park, and then I would get cross sections and long sections for car park. Rather than outputting the contours for total model, maybe I want NS there. So there is this what we call thread mapping option as well. So if you've created a thread for a particular string, you can run it on another string or surface there. Okay, let me just do another example of threads. And what I might do this time, because I'm running inside Civil 3D, I might tell the software that I want to output a Civil 3D surface. And the other thing I might do is tell the software that I want to output the datum surface as well. We often get asked about how the auto model datum gets refreshed. At the moment, you have to constantly run auto model datum. So tying this into a thread will certainly be a benefit as well. So this time I'm going to right click and open up the thread editor, and I'm going to add a new one, and I'll call this one, I'll just call it model update. So the first thing I'm going to do here is tell the software to output the datum surface. So under model computations, there's update auto model datum. So I'm going to add that action in. And then the next thing I'm going to do is output a civil 3D surface. And I'm going to do that for total model. Alright, so once I run this thread, I'll get the datum surface and the civil 3D surface will update as well. Just want to mention that you can run threads from the thread editor as well. And if you see just above that button here, there's a blue link called no, currently the text is no issues found. And you'll notice the same on the run thread form as well. Now, you might create a thread that references a certain string, but you might have deleted that string or alignment or surface or whatever, so it doesn't exist. These are the types of error messages that the software will report to you. Things like, hey, I tried to process for this string, but it was deleted, or I tried to output contours for this surface, but the surface doesn't exist. We'll report all those issues for you. It's one thing that we want to improve on, and that is the error messaging back to the user. So let's close that, and I'll just run the model update. Alright, now if I go over to my tool space, firstly I can see that that civil 3D surface now exists there. So the software's outputted a civil 3D surface in the background, and it's also outputted my datum surface. So if I was to click on toggle display, you'll see I've got the datum surface there as well now. So yeah, it's really just as simple as that to build up the thread. I'm not going to go through and show you every single action, demonstrate every single action. A lot of it's pretty self-explanatory, the sort of things that you might want to do, but there's just some common examples. The final thing I wanted to do is just show you an example of using the match to existing, because I think this would be a common use of threads, where you might have intersections where you don't want to use the curve return command, and you want to manually build up an intersection, or you might have cases where you want to model in a driveway manually. So, and often in those cases you want to use match to existing to set certain parts of your your returns to connect into an existing road or whatever. So what I've done here is I've created a string. It's called car park. I've actually already modeled it using Model Builder, so I'm just going to go to toggle display, and I'll just turn the line work on for that final model. And I'll just delete that civil 3D surface there. In fact, I might just do a drawing cleanup to get rid of that, the lines that I've outputted. Okay, yeah, so all I've done here is I've jumped into Model Builder, and I've just told the software to connect the car park back into Marin Street. So all I've done is created a string and added it to the model there. Let me just very quickly fix up this. I think I just have to resample some sections on my road just to tighten that up a bit. I'll just quickly rerun that. Yeah, okay, that's good. Okay, so I've created this string, but it's not connected into the road. I'm going to use the match to existing option to tie the levels into the road. In fact, Let's just open up Model Viewer to see how it looks at the moment. I'll just zoom in. It looks absolutely terrible. So I've created that string independently, but you can see that the curb is all the way up here as my road curb is down the bottom there. So what I want to do is manually connect the entrance to the car park into the main road, and I want to set this up as a thread so that every time I change my road levels, all I need to do is update the thread to update the connection here. So I'm going to open up the vertical gradient editor for the car park, and I'm just going to tell the software to tie in the ends here. So I'm going to use Compute VC. I'm going to click on Match to Existing, and I'm going to say for the first 2 meters, match the levels to total model. Alright, and then I'm going to go to the other side and do the same thing. In fact, I might just lower that through there. Okay, I'm just looking at the changes. I probably want to match from about 117, we'll go 118 to the end. So I'm going to go match to existing again and say from change 118 to the end, match the levels to total model. Apply. Okay, so if I was to open up Model Viewer now, things should look pretty good because I've matched everything in, which it does. However, as I've been saying, if I move the road up and down, I'd have to go back into that Compute VC and reprocess. But if I tie it into a thread, then I don't have to do that. So I'm going to create a thread to update this intersection. So I'm going to go and open up the thread editor and add a new thread, and I'll call this one intersection update. Will do. So all I really want to do here is firstly, if I change the road, I want the software to recompute the car park string. So under string computations, I'm just going to add compute vertical geometry, and I want to recompute the vertical geometry for car park. And after I've done that, I just want the software to rebuild my model builder model. So I'm just going to add a compute design models after that and make sure that's down the bottom. Right. So order of operation is important here. Update the vertical geometry first, and then update my model. So let's open up the Run Threads form, intersection updates there, and I'm going to open up Model Viewer so we can see this change. Alright, so it looks good at the moment, but let me just go in and raise the road levels. So it's going to lift the main road up through where that car park is. Alright, and you can see that things aren't looking too good because I've lifted the road up and the entrance to the car park's lowered. So if I right click on intersection update and run the thread, you can see that everything is connected back in again. Alright, and that was just 2 entries in the thread, update the vertical geometry and then rebuild my model, and that's it. So that's just some examples of using threads. I mean, you know, and even in this demonstration here, I've added a few different, 3 different threads. But as I said, I could have tied all that into the one thread. You could have one thread for the project that does everything that you want, design related. But you might have another thread purely for, for output. So if you need to, reset out your project, update cross section, long sections, etc. You could tie all that into a planned production thread or something like that. Look, one last thing I'll show you, only because it's sort of unrelated to threads, but we've got some new features coming, and I thought I might as well just chuck this one in at the end here. I've just going to turn on the contours for the model I have here. We have a number of different new improvements coming soon, and while I've got Model Viewer open, I'll just talk about a couple of those. Firstly, we can now show the contours in Model Viewer. So if I click on Toggle Display, there's a tab that gets added called Contours, and all it does is it lists all my surfaces, and I just pick what surface I want to show contours for. So I'm going to pick on my BM model, click OK. Alright, then you can see those contours appearing now in Model Viewer. They display really fast, and we've done some tests on larger surfaces, and yeah, the speed of this is really quite good. The other thing worth noting in Model Viewer is we never really did a good job of boundaries. So if you had added boundaries to your natural surface or whatever, we'd still sort of triangulate across. We never really took notice of the boundaries. Now we do. So if I was to add boundaries to my base surface here, Model Viewer will now honour those boundaries. So just wanted to chuck a couple of those things in. As I said, in the next few weeks we do plan to release this version, and yeah, unless we encounter any setbacks or whatever, it should be out quite soon. Okay, so this is all I wanted to show you today. I hope that you now have an understanding of what Threads will allow you to do. When we do release this new update soon and you see Threads on the ribbon, I hope that you're keen to have a bit of a play around with this new functionality. And we do appreciate the feedback, both good or bad. So if you do have any suggestions, then we are all ears, so get in contact with us. And you can get in contact with me directly if you like. I'll just put my email address on the screen there. So yeah, if you just want to pop me an email, feel free to do so. Okay, so look, if anyone's got any questions about Threads, you know, feel free to ask away in the chat window or the Q&A window, and I'll do my best to answer your questions. Oh, seems like we've got a couple here. Let me just open up. Okay, first one, will Threads cover pipes? Not at this stage. Now, the reason for that, if you didn't already know, we're actually working on a new pipes module. And once we finish that pipes module, then Threads will be included. The only thing from pipes that is included is label update. So if I go back to the thread editor, you'll see that there's a thread called Synchronized Labels. So any labels that you output in civil site design, these could be, you know, surface labels or you know, pipe labels, this synchronized labels will update. In fact, on a lot of the threads that we've added to the software, you'll notice down the bottom we have a synchronized labels as the last thing we do. So pipes not yet, but when we finish the new module, yes, but pipe labels will update. Question about intelligent sections, they will update as well. So if I go back to the thread editor, when you add a thread to, or an action to compute design data, it basically runs through the entire design data form. So everything in this design data form gets reprocessed, all the variations, all the batters, including the intelligent sections. So yeah, intelligent sections will update if you add the compute design data option. Okay, well, doesn't seem to be any other questions coming through. if you don't want to ask them now, then feel free to. Oh, we've got another one. I'm not too sure whether the question is related to threads, but yeah, I'll only answer questions related to threads at this point. If you've got other questions, then okay, just got a question. Can we share the threads? Each of these threads just get outputted to a text file. So let me just bring my Windows Explorer here. So whenever I create a thread in the data folder, they just get created as a text file, and you just drag and drop them in your data folder. There's a folder called batch list, which is actually what we originally named the command. So you just copy and paste them in there, and there'll also be a batch list folder in your common tent, so you can just copy and paste that text file into there as well. Yeah, good. It's a good question. When you output threads to plot long sections or cross sections, is there a template? What we do at the moment is the process would be this: you would go in and already have set up your long section and cross section. So whatever I've got set up in here for long sections, or if I go and plot cross sections, whatever I have set up here is what the software is going to use. So the first thing you would do is go and plot the cross section, apply the style, and the threads are just used to re-update those. Not sure the next question. Can a user add an action to thread editor? I guess you're referring to, can you create your own actions? Look, this is a watch this space. I won't say much on it, but there are a lot of thoughts on the ways we can open things up more to users. So yeah, watch this space on that one. We've got some plans of different things we might add to the software later. But we'll certainly be growing this actions list. And if there is a command on the ribbon that you use all the time and you think, oh, geez, that would make a good action so I don't have to re-update it all the time, then let us know and we can add it in. We've sort of done our best to try and find every single one that's common. Even things like slope patterns are there. If you put slope patterns on your batters, yeah, I mean, most of the common ones are there. Even resampling the string. You might have a job where you've changed your sampled surface NS to something else, and you want to resample your whole project to use another surface. That resample string would be great for that, because you could say, I want to resample all strings against a surface that's updated. Okay, cool. Well, yeah, as I said, if you've got any other questions that you think of later, feel free to email us and get in contact, either through the support, or you can email me directly as well. So thank you very much, everyone, for attending, and I hope you all enjoy your weekend.